Hello everyone. Welcome to 60 Seconds to Code, where I show you how to code in 60 seconds or less. Maybe I'm thinking about changing the name of my channel. These are no longer 60 seconds, but 60-minute videos. But I think I'll continue my 60 Seconds to Code videos, perhaps in the future. But today, what I'm going to be doing is I'm going to be doing part 3 of my AWS, basically the web chat with AWS, Lex and Lambda and CloudFront. Today's video number 3. And today I'm going to be showing how to deploy the infrastructure which I used last time to deploy in the console. I basically deployed the entire infrastructure in the console using console. How to deploy that using infrastructure as code, specifically using Terraform. So let's get into it. On the agenda today, I'm going to go over some definitions and technologies. I'm going to give you the architecture. Again, my apologies. I'm wearing a dental implant. That's why you're hearing that lisp. So moving on. Architecture, I'm going to give you an overview of the architecture. The architecture is exactly the same. No different as before in the last video, which is part 2 video. In the part 3 video, which is today, the only difference is we're going to be deploying the architecture. Instead of doing it manually, we're going to be doing it automatically using Terraform. So, and then after the overview of the architecture, we'll actually do the demo and actually deploy the architecture. So on to some definitions for today. Infrastructure as code, or IaC, it's something that most architects and developers should become familiar with. Or if you probably are already familiar with, but if you're not, you should definitely become familiar with. Infrastructure as code is the process of managing and provisioning code such that it becomes readable, and you can provision infrastructure in machine-readable definition files rather than actual configuration tools. I don't know why that word CloudFront is there. I think it's a remnant from a previous presentation that I was changing, but that's neither here nor there. Terraform. What is Terraform? Well, it's an open source infrastructure as code tool, and it's developed by HashiCorp. In it, you can define infrastructure using declarative configuration languages that is known as the HashiCorp Configuration Language. And you can also use JSON if you like, if that tickles your fancy. But using these declarative, files, you can create your infrastructure as code. Basically, these files you can then check into a source control repository. And every time you run Terraform, specifically the commands which we would need to run with Terraform, I will go over in today's video. But as soon as you run those commands, the infrastructure, as you anticipated, is going to come up the same every time because it's under source control. And because it's declarative, it will only read those files and only create the infrastructure as it's defined in that file, in that source control file. In this case, the HCL files. Sorry, not the HCL files, the Terraform files. The language is written is going to be in HCL. Let's go over the infrastructure. As usual, it's the same that we did last time. The user is going to be interacting with the browser. The browser is going to be connected, or they're going to be typing in Route 53 domain within their browser window. CloudFront is going to be fronting an S3 bucket, and this S3 bucket is where all the static site content is going to be hosted. CloudFront is also going to be protected by Certificate Manager, and the JavaScript and the HTML file that I chose to show you guys last time, which is exactly what we're going to be using today, is basically the ultimate chat widget that we're going to be using to connect to AWS Lex. We will get to that in a future video, I promise. But today, I wanted to show you how to deploy this entire infrastructure. Last time, it took me roughly 47 minutes to deploy that infrastructure using the video. And I, by the way, forgot one step. You will notice what time it'll take me for me to do it this time. And obviously, I cannot forget any steps because, well, it's declarative and computers don't forget. And the infrastructure will come up the same every single time. Oh, by the way, all of this is going to be deployed. This entire infrastructure is going to be deployed using Terraform. Again, this demo is not in the free tier, so you're going to be incurring some costs. If you're going to do the demo, it's your responsibility. It's part of your due diligence to make sure that you know what cost you're going to be incurring. The costs are including, but not limited to, the cost of the Route 53 domain, the cost of the CloudFront distribution that you're going to be creating, the cost of the S3 hosting, as well as cost for the ACM certificate that we're going to be deploying. The cost is going to be minimal. After this, video, after I bring up the infrastructure, I'm also going to destroy the infrastructure. So if you follow along with me, creating and destroying the infrastructure, it should be extremely minimal cost. But if you leave it running, If you leave the infrastructure running, that's when you will start to, incur some costs. Well, that's neither here nor there. Let's get into the demo, shall we? Okay, the very first thing we have to do is we have to clone the Git repository. The Git repository in question is going to be this Git repository. And I'm going to provide a link of the Git repository in the video description below. And within this, I have created a Terraform script that I'm going to clone. So git clone, and there we go. Go ahead and let's go ahead and fire up Visual Studio Code and open that. And there is my Terraform code. You know what? I will come back to this Terraform code in just a second, and this entire setup in just a second. But let me go over the how to configure AWS because in order for you to be able to work with Terraform, you first have to configure the AWS CLI. If you have not downloaded the AWS CLI on your machine, go to Google, type AWS CLI, and you will be able to download the latest version of the AWS CLI. And then after you download the latest version of the CLI, you need to configure the AWS CLI with credentials such that they will be able to perform everything that we're going to be performing, which is we're going to be creating S3 buckets, etc. In my case, I'm just going to go, use a sledgehammer. I'm going to go ahead and use my master credentials. And by the way, you feel free to copy my credentials. I'm going to delete them after this video anyway. If you want to use them, you're not going to be able to hack into my account. I'm going to make sure of that. But let's go ahead and go to IAM and generate credentials from my master account. I'm going to go to IAM. I'm going to go to my, users, find my user. And for this user, which is my master account user, I'm going to basically this user is in the admins group, so it can do anything it wants to in my personal account. In most environments, which is going to be, enterprise environments, they're going to expect you to use the least privilege role in order to execute this. But for the purpose of this demo, I'm going to use this user who has full administrative privileges, and I'm going to generate my IAM security credentials. It looks like I already have a pair of IAM credentials, which I am going to delete right now. I'm going to go ahead and deactivate because you guys have already seen it. I'm going to deactivate and delete this one. Bye-bye. And I'm going to go ahead and create a new access key. You will need to follow along in your AWS account and do this exact same thing if you want to do it. And I'm going to go ahead and download the CSV file. And open the CSV file in Excel. And I should get my access key ID and the secret access key. So let's go ahead and go to my command line. By the way, at this point, you should already have the AWS CLI installed. Not AWS configure. And now you need to run the AWS configure command. Now, when you run the AWS configure command, you need to provide the credentials, the access key ID, and the secret access key for the account that has the privilege to bring up the infrastructure in your account. In this case, I'm just going to say US East 1, and the format is table is fine. So now I have configured my AWS CLI, and with these elevated credentials, using the AWS CLI, I can create as much infrastructure as I want to. However, I'm not going to use the AWS CLI to create the infrastructure. I'm going to be using Terraform. And Terraform is a wrapper around the AWS CLI. What Terraform is doing underneath the hood, all it's doing is all making the same API calls that we're all familiar with in order to interact with the AWS cloud. So what we did right now was we cloned the repository, and then we also run the AWS configure. All right. Again, I'm going to include a link in the description below on the official Terraform website. Go ahead. You're going to need to download the Terraform CLI in order for you to be able to follow along in this video. But let's see if Terraform is installed on my machine. I'm pretty sure it is. I think it's --v or -v. I don't remember what command is to get my version, but I believe Terraform is installed on my machine. If not, there it is. Terraform is installed on my machine. If not, I was going to pause the video and go install it just to make sure that I do have it installed, and I do, on this machine that I'm recording the video on. So I should be good to go. I'm going to provide you a link where you can go and download Terraform, the Terraform binary. So now that we have cloned the repository and ran AWS configure, let's go ahead and go into the code a little bit. Before we run into any of the Terraform commands or like that, we are going to go into the code a little bit. What you're seeing on your screen is the exact configuration of my repository if you were to clone it in your local machine. This is what it's going to look like. The very first thing that I usually like to talk about in any Terraform configuration is the main.tf file. So let's go ahead and take a look at the main.tf file. Within the main.tf file, I have configured the Terraform block, and the Terraform block you have to specify the provider. In this case, the only provider, or in this case, the cloud. You can think of a provider as a provider of resources. In this case, the provider that I'm configuring is AWS, and the resources that I'm going to be creating include things like an S3 bucket, a CloudFront distribution, files, not files, what is that called? The Route 53 domain and the records on the Route 53 domain, the certificate manager certificate, all that stuff. Therefore, I need to let Terraform know that in this particular Terraform configuration, I would like to use this required provider, which is AWS. You can copy my code if you want to for their future purposes. By the way, I have commented the heck out of my code. Everything that I'm describing or glossing over, I've put in detailed comments. So when you clone your repository, you will find my comments in there. And I've provided you links on the documentation as well. You'll be able to find a lot more good information if you want to get into the depths of it. Now, every provider requires different configuration. One of the things that the AWS provider in this case that requires in order for the AWS provider to be configured is the AWS region. And what I'm doing is I'm providing the AWS region as a variable value. Now, the variables, this is a good segue. The variable values are defined in an external file called variable.tf. So let's go ahead and take a look at variable.tf file. Now, within this variable.tf file, I have multiple, variables that I'm defining. And this is only the definition of the variable. In this case, the values of where those variables are going to be coming from, I will go over in just a second. And by the way, I think I may have my notes. There we go. There are my notes. I'll come to this in just a second. Now, let's go back to our regularly scheduled program. This is where the definition, the variable.tf file is where the definition of the variables are. But the values of these variables actually exist in what is called the tfvars file. And in this case, this is the dev.tfvars file. And notice all four of the the dev environment variables that I'm describing, the domain, the AWS region, the developer name, and the environment, their actual values are included in, where did it go? The dev.tfvars file, which is this one right here. The only thing that you would have to do, by the way, when you read through my repository, the couple things that you will have to do is change the domain name. In my case, the domain name that I purchased and in Route 53 that I've entered on, I'll go over that in just a second as well. The domain name that I've purchased and I'm using for this demo is codeislife.de. It was a cheap domain that I was able to purchase. You can go ahead and go to Route 53 and purchase a domain for this purposes, but again, be warned that is a cost that you're going to have to incur. But this is the value of the AWS region that we're going to be passing into this main.tf file as an environment variable. This is the region, and var.aws region is what we're going to be passing. Now, how this is going to be passed as a command line parameter, I'll go over that in just a second. But also, when you clone this repository locally, change the name instead of my name, use your name, obviously, and the environment value, which is going to be dev. And if you want to, change it to prod or pre-prod or test or whatever, that's totally up to you. But I'm using the dev as the environment value. Okay, moving on from main.tf. S3 origin ID. Okay, locals is a method of defining variables or defining values that you don't want to define in your environment variables file, which is the var.tf files, but you still want to use them. In this case, I'm using tags because I'm going to be tagging all of my resources with these tags, and I'm passing the variable of the developer name along with the environment as the tag values for the owner tag as well as the environment tag. Then you will see I will be using local.tags in my the Terraform script over and over again. So that is my main.tf file. Now, let's go back and take a look at what we were going to be creating, right? What we were going to be creating is, number one, a Route 53 domain. Then that is going to be fronting a CloudFront distribution and the certificate manager. So let's go ahead and go through each of these at a time. Let's go through the Route 53 domain first. If you want to read the details of how I'm configuring all of this, if you want, you can watch the previous video about how I'm manually configuring it. But the actual Terraform code, I won't go into too much detail, because if I was to go into this, it'll be another 2-hour, 3-hour long video, and I simply don't have the time. Just know that the links that I have provided you up here, you can go and read the resource documentation from the Terraform official docs and figure out how I am creating the ACM certification validation, the Route 53 domain, the Route 53 domain records, so forth and so on. You can go ahead and read about all that. But this is the route, every configuration in regards to Route 53 and how Route 53 needs to be configured, which is this piece right here, is defined within this Route 53.tf file. Okay. Now, you must be thinking, how is Terraform going to know that to execute this Route 53 domain and this IAM.tf and main.tf? How does it know? Well, whichever working directory within which you perform the Terraform commands, which we're going to go over in just a second, it will consider that entire directory containing all TF files, and every TF file within it, it will attempt to execute them when it, using what is called a dependency graph. Go over that dependency graph in just a second as well. Next, obviously, what we need to talk about is the other pieces. Route 53 domain, let's look at the CloudFront distribution. So let's find the CloudFront TF file right here. And again, the entire configuration of the CloudFront distribution, which is what I showed you manually, this is how you would configure it in Terraform code. Okay, everything that I did manually in last video, this is how you do it. And again, go ahead, read through the documentation if you want to. But because today's video is not really about the details of Terraform, otherwise, this will turn into an hour, 2-hour, 3-hour long course on Terraform. Let's go ahead and take a look at the ACM certificate manager file as well. And let's go ACM, where did it go? CloudFront, dev.tf, main, Route 53. Where did I put the certificate? I can't seem to, maybe I did not put it in a separate file. Okay, ACM. Oh, it's there. I keep missing it. There it is. There's the ACM.terraform file. I don't know why I was thinking it wasn't there. Again, all the configuration related to the ACM certificate and how to configure it, well commented. You will find links to the official documentation in here as well. Go ahead and read through it. But the only purpose of this quick description of what I'm doing is that I am declaratively describing for Terraform that I want you to bring up this architecture like this using the Terraform's HCL, which is HashiCorp Configuration Language files. There are multiple files in here. One is called acm.tf, one is called CloudFront.tf, blah, blah, blah. How I'm configuring and the one-to-one, configuration of what it looks like from the previous video to this video, I'll have to go into a lot more detail, but I don't think I'm simply not going to have time for that. So go ahead, read about it. But what I'm doing right now, just as a general overview, for each of these, or for what Terraform does, is as part of the Terraform configuration, what it needs to do is it needs to create what are called resources in the provider that we have configured. So what we talked about earlier was the Terraform block that I configured the AWS provider in, and then I configured the AWS provider to use the US East 1 region that is filed within the AWS region, and that's going to be within the dev.tfvars file. Now I'm using the rest of these files that within this AWS provider, I want you to configure a Route 53 domain, an S3 bucket, and the following IAM resources, the following CloudFront distribution, the following ACM certificate. Everything that I did, everything that I created in the previous video, I'm declaratively creating within these Terraform files. Okay. These are what are called resources. In this, let's go ahead and take a look at a simple resource. Well, not simple, a rather simpler resource, which is called the AWS S3 bucket. The AWS S3 bucket is the one that is going to be hosting my static content. And this is how I'm naming the bucket, and you can go ahead and read about the details of it. But if I was to use just this piece of Terraform code, what this will do is it will create a very simple one little S3 bucket. Okay, one little S3 bucket, and I am good to go there. However, what I also want to do as part of this is I want to create multiple S3 bucket objects. And the definition of those objects is included within this file. And the static files, if you remember from the last video, the index, the simple chat JS file, the jQuery JS file, the bootstrap nin, the images, all of that. I'm passing this as a locals variable, and for each of these, I am uploading an S3 bucket object or a file to this S3 bucket. What this is going to do, and this is a quick introduction of the dependency graph. What this will do is it will basically, Terraform will read this HashiCorp, these HCL configuration files, and will recognize that, okay, this is an AWS S3 bucket item or object, right? But in order for me to be creating an object in an S3 bucket, what do I need to have? Well, before you can put any object into an S3 bucket, you need the S3 bucket itself, right? Without that, you can't create it. So what it will do, it'll come here and it'll say, okay, what's the bucket to which I need to create or upload this object? And it will recognize that the bucket to which this is configured is the AWS S3 the bucket for static content. All right, so it'll say, okay, I need to create this S3 bucket, which is the bucket for static content. I need to create this resource before I attempt to upload any of these resources. And I'll put this in the dependency graph. Therefore, within the dependency graph, it will be defined that these objects must be created after this S3 bucket is going to be created. That is what is called a dependency graph. And which resource needs to be created before which? Terraform will do for you. This seems to be a tripping up point for a lot of beginners. You're like, wait, how do I define? Because a lot of people who are coming from programming backgrounds, they're like, what needs to happen first? I need to completely control the flow of when everything created, which resource gets created first, which resource gets created second, so forth and so on, so that I can control that. No. The beautiful part of HashiCorp's Terraform is that it manages that using a dependency graph, and which resource needs to be created before which one, it manages for you using what's called a dependency graph. So you don't have to worry about this. All that you need to specify is that for these objects, this is the bucket that these objects need to be uploaded to, and it will know that, hey, I need to create this bucket before I attempt to create any objects. And again, similarly, if you watch my previous video, how I went about creating which pieces before which pieces, all of that is going to be described declaratively within these files. Okay, moving on. So we talked about what is a Terraform provider. What we also need to talk about is what is called a Terraform state file. Okay, Terraform state is how Terraform manages what the state of the infrastructure looks like. For example, now that I have this, once I run the Terraform, when the Terraform apply and deploy, all these infrastructure resources are going to come online. And when these infrastructure resources come online, it is going to be Terraform's responsibility to make sure that this state of this architecture is exactly as it's supposed to be. For example, I go in and I deploy this, and this beautiful infrastructure comes online exactly as expected. Okay, the Route 53 domain is configured, the CloudFront is configured, the certificate manager certificate is configured, the S3 bucket is configured, all the items, which are the static items, are uploaded, and it's all good. But I forget something, and I'm like, you know what? I don't know what this bucket is for. I go in, I clean up the bucket, and I destroy the bucket. Okay? What's going to happen is Terraform now needs to recognize that, hey, next time somebody runs Terraform apply, or next time somebody attempts to bring up this infrastructure, this S3 bucket needs to exist. That record of what that S3 bucket needs to be and what it's supposed to look like, etc., is stored what is called within a state file. Currently, we're going to be storing that state file in my local machine. They're using S3 as a backend. You can even store the state file in an S3 bucket, or you can use what is called Terraform Enterprise to store, configure different backends. You can use many backends. I've used GitLab as a backend. I've used Google's static. I forgot what it was called, but it was a blob object storage as a backend. I've used S3 as a backend, but today I'm going to be using local, which is going to be my machine, as the backend. And that backend, in this case, is what's going to store that state file. Now, that state file, once I do an apply, or once I deploy these resources, after all the resources are going to be created successfully or unsuccessfully, whatever the case may be, it's going to store the state of this entire infrastructure in that state file. And what we'll do is next time I attempt to run an apply or deploy or anything like that, it will go back and check, see if that static content bucket exists or not. And if it has been made any modifications, if it needs to be private and somebody maybe changed it from private to public or something like that. If that's the case, what it will do is it will recognize that there is a delta between what exists in the infrastructure currently and what it needs to be. And it will attempt, again, run the deploy again, and attempt to bring up the infrastructure in the exact configuration that it is supposed to be within these declarative files. What this means is that what I want you to do, and this is an exercise I want you to try, is once you run this yourself, I want you to go into your AWS console and attempt to delete maybe some of the S3 bucket objects, or maybe delete this S3 bucket. And once you delete that S3 bucket, I want you to come back and run the Terraform apply again. We will go over the commands in just a second. I want you to deploy your infrastructure again, and you will see what Terraform will do. All the dependencies it needs to manage, whether it needs to create a new S3 bucket, new S3 objects, perhaps it needs to update the CloudFront distribution, perhaps it needs to update the Route 50 domain records, all of that it will take care of for you. And all of a sudden, if you accidentally delete something, your infrastructure will come back online exactly as it's expected to be. Exactly as it's expected to be. That's the beautiful part about Terraform. And there is a quick primer on Terraform state and how Terraform detects drift, or in this case deltas, about changes from the local versus local state or any state file versus what it actually deployed. And now let's go ahead and have some fun. Let's go to the terminal, start a new terminal, and run what is called the Terraform init Terraform init command. What Terraform init will do is download what is called, or what are called, modules. In this case, it recognizes that I need to download all the plugins and modules in order to be able to create resources within the AWS provider. If I had configured some additional providers, for example, people are now obviously authoring multi-cloud solutions within Terraform. Perhaps you want to host your content in an S3 bucket, but perhaps you want to, front it with Google's CloudFront, Google's equivalent of CloudFront, or some other CDN. That's totally up to you. You can configure multiple providers. In this case, I'm only showing you within AWS. But this init command, what it did is it initialized the required provider and all the plugins and resources it needs in order to be able to create resources within the AWS provider. So that's why I ran, the very first command I ran was the Terraform init command. And let me show you what that command looked like. Terraform init, Terraform init. Okay, so that's what you're going to do after you clone the repository. And now that you've gone this far, you're going to run Terraform init in your local repository. Then what we need to do, we need to run what is called Terraform validate. What Terraform validate is going to do, actually, you know what? Before we even run Terraform validate, let's run another fun command that's called Terraform fmt. Now, in my case, I don't think, Terraform format didn't do anything. But sometimes while I'm writing my Terraform files, Terraform is actually not sensitive to space and tabs like Python is, for example. But if you do something and the file looks funky, in this case, my main.tf file now is starting to look funky. what it's going to do, I'm going to run Terraform format, and notice it changed main.tf back. And now if I go back, reopen main.tf, it is now formatted as expected. Now, that wouldn't have mattered because Terraform is not sensitive to, tabs and spaces, unlike Python. But in this case, now it's all your code, the HCL code is nicely and neatly formatted. I really do like to run Terraform init and then Terraform format before I like to do anything. That way my code remains my HCL code remains in a beautiful state. Now what I'm going to do is run the Terraform validate command. What Terraform validate is going to do is, after, obviously, you have to run these commands in these, in this sequence, by the way. Using Terraform init, it configured the provider, in this case, the AWS backend, all the plugins, all the, providers it needs to download it. But then, using Terraform validate, what we need to validate is all these Terraform files that I've written, whether it's main.tf file, whether it's im.tf, or any of the other Terraform files, whether this is valid Terraform configuration. What this will do is, you can think of it as almost like a build time versus compile time, right? That's something most programmers are familiar with. Terraform validate is basically a build time command. It will make sure that any of these, for example, if a resource, I'll give you an example that should fail this Terraform validate. The Terraform validate should specify that, or should recognize, I'm going to go ahead and comment out this region. Using Terraform validate, it should recognize that, hey, for this particular provider, the region is a required value. And now if I run this Terraform validate, it should throw an error for me saying that, hey, within your provider, you have not configured a region. So let's go ahead, run Terraform validate after making change to the main.tf file and wait for the output. Nope. Wait a minute. That should not have. Maybe that would be a runtime thing, or maybe I didn't save my changes. Maybe I did. I don't know. Configuration was valid. You know what? Let's go ahead and do something really funky. Let's go ahead and go to S3, and yeah. For these resources, this S3 bucket object, obviously the bucket name is required. Okay, the bucket to which this is going to be deployed is required. So I'm going to go ahead and make that. This is definitely going to cause a validate problem. So let's go ahead and run Terraform validate now. And now what I should see is build time. It will tell me that, hey, for these S3 bucket objects, you need to specify a bucket, which is exactly the error I got. There is a missing argument in this S3 bucket object, the static content, and it needs to be the bucket value is a required field, and no definition of it is not found. So now I'm going to uncomment it. Whoops, shouldn't have done that. Uncomment it and run Terraform validate again. And this time my validation should succeed. Let me make sure my main.tf file is exactly as it's supposed to be, and it is. And now my Terraform validate should be successful. Okay. Excellent. Okay, after that brief interlude, let's get back to it. One thing that I do recommend that you guys do is purchase a Route 52 domain if you don't want to incur costs of that. I don't think you're going to be able to follow this. You're just going to have to watch the video, because without purchasing this Route 53 domain, you're not going to be able to follow along in this video. But you can purchase a cheap Route 53 domain. In this case, I think I spent like $9. I don't remember what money I spent. But I have two domains currently that I'm managing within Route 53. One is called codeslife.net. The other is called codeslife.de. And within AWS, I have an Route 53 managed zone, which is this hosted zone right here. And all the records for this codeslife.de Route 53 domain are going to go into this. So what I recommend you do before you begin, obviously if you're not before you begin, but if you're going to follow along in this video yourself, go into Route 53, go to domains, go ahead, purchase a domain, And once you purchase a domain, it's going to get registered on Route 53. And I will provide a link in the description below on how to purchase domains using Route 53. And you will get a hosted zone. This hosted zone right here in this cloud code is life.de. All the records, which is going to be your DNS records for this Route 53 domain, are going to go into this hosted zone. But the only reason I don't want you to delete this zone, or I don't want you to create this zone using Terraform, is that if you were to do that, and Terraform attempted to destroy and recreate this Route 53 hosted zone, what's going to happen is it'll take a very long time for the the DNS records for this hosted zone to propagate throughout the World Wide Web. It'll take a very long time. So I would recommend is once you purchase the domain, leave this hosted zone alone, and then run the following command in order to import the Route 53 zone into your Terraform state. And this is the command that I'm going to run for you right now. Let's see if I can. Maybe I can make this bigger so that you guys can see. There we go. This is the command I'm going to run. And I'm going to give you an overview of what this command is going to do. Just like I talked about just a second ago, Terraform's responsibility is to make sure that your configuration is exactly what it's supposed to be. One of the ways that you can do is, because, well, in this case, I'm not creating this hosted zone using Terraform. I'm actually importing it. And if you go to Route 53, which is my route53.tf file, this is the resource that I'm, hosting. I'm sorry, the zone within which I'm importing this. So now what I'm going to do is I'm going to run this command, and I'm going to import this zone into Route 53 so that Route 53 becomes aware that this is the zone to which all of my Route 53 DNS records need to be deployed. So let's go ahead and, by the way, you're going to need to change this command to follow your needs. The only thing you will have to change is the zone ID. And in order to find the zone ID, you can just go to Route 53 and find the zone ID under the hosted zones on the rightmost side called hosted zone. Your hosted zone number obviously is going to be different. I'm going to go ahead and run this command. And what this will do is it will create a state and file and let Terraform know that, hey, this hosted zone is already created, and now Terraform is starting to manage and successfully imported this resource, and now Terraform is starting to manage this. Now when I apply all of these records, because all these Route 53 records, this particular record, as well as the namespace records and CNAME records, all of that need to get deployed. What this will know is it'll let Terraform know that instead of creating this, you already have this imported. This already has been created. Go ahead, write this record as well as this record as well as these records to this zone that you imported just a second ago. The only reason I'm doing this is because last time I did this with Terraform, it took like 48 hours for all the DNS records to propagate. That was a very long time. That was not fun. So don't do that. Go ahead, create the hosted zone, and then use the command that I showed you to import it. I will put the commands in the description below as well. Okay, so now we did the Terraform import, and now we are on to do the fun part, which is these commands right here. We're going to run Terraform plan. Now, what is this Terraform plan file? The Terraform plan command. What the Terraform plan command is going to do, it's going to figure out what resources have already been created. For example, in this case, one resource already exists. The hosted zone already exists. We already imported. And what it will figure out is, in order to bring this infrastructure into this current configuration, which is the Route 53 domain, by the way, the hosted zone we already created and we already imported. But it will know that I need to create multiple, records, just like I showed you in the previous video. Those records it will create. The CloudFront distribution needs to create. The certificate manager, the S3 bucket, and the S3 bucket object it needs to create. It will know that, hey, I need to add 24 of these items into by creating them and then adding them to my state to make sure that I start tracking them. So this plan command, what it will do is it'll do exactly, just tell you what it sounds like, tell you what it's gonna do, but it's not gonna do anything. You can read using the output of this, exactly what it's going to do, and it's going to describe for you each of the resources that it's going to create. In this case, the resources that is describing that it's going to create and it's going to add, it's saying that the jQuery file is going to be created, and the resource is going to be the AWS S3 bucket static content. The type of it is going to be a static content. The bucket name and other things are going to be known after the fact, and other things. You can read about all the things that it's going to create as a result of this plan command. For example, the Route 53, the S3 bucket, the Route 53 records, all of those 24, in this case, items and resources that it needs to track, it will create for you. But the plan, all it does, it gives you a plan of what it's going to do. It's not going to do anything at this point. The plan is a safe command to run. The reason it's a safe command to run is because it's not going to bring up any infrastructure. But in order to bring up the infrastructure, in this case, the infrastructure that is, we're going to run what is called the Terraform apply command. This Terraform apply command is the one that is actually going to start to attempt to bring up the infrastructure, actually attempt to create the Route 53 records, actually attempt to create the S3 bucket, actually attempt to upload my static files into the S3 bucket. By the way, all that static content is loaded within the static content folder. You can watch the previous videos for that static content and where the location of that static content is. And if you are interested on how I'm going about uploading or creating the static content resources, which is the index.html, the jQuery file, the bootstrap file, you can read the s3.tf file. I'm not going to go into the details of this. You should, but obviously, if you want to modularize it or change it for your purposes, use my code, but obviously change it as necessary. In my case, I'm just going to bring up as it is. Okay, and now I am ready, based on this plan command, that I am ready to apply and create these 24 resources. Again, it will, under the hood, the apply command will also run another Terraform plan, but this time it'll ask you for a confirmation and say, are you sure you want to perform these actions? You can suppress this by using what is called the, I think, either auto approve or something like that. I don't remember the auto approve flag or the flag which you can specify in which you can suppress this, but I usually don't like to provide this flag, that flag. I usually do want to think about the resources that I'm going to create. In this case, I'm going to specify, yes, go ahead, create these resources. Now, what it will do is it will bring up those 24 resources so very fast. Okay, let's go ahead and let's let it do its thing for a while, and let's go ahead and watch the execution of the entire script. Okay, what it's doing right now, it's creating a record for the Route 53 domain, which is going to be the code is life.de. It is then also creating a record for the Route 53 domain. It is going to create another Route 53 domain record. It's creating the namespace records, and then it's creating other namespace records, and it's creating other things like that. 30 seconds have elapsed, by the way, and it's already gotten through what I did for, I think, in 30 minutes last time. Okay, and now it's starting to create the CloudFront distribution. There you go. There's the CloudFront distribution coming online right now. Woohoo! And this might take a while, but if you want, you can read the details of what it's doing using, hey, it was created a Route 53 record, and it created the S3 bucket, and after it created the S3 bucket, it created the S3 bucket objects, so forth and so on. And right now it's creating the CloudFront distribution. This part usually takes a while. Last time I timed this I think roughly took like 2 minutes. So I'm going to go ahead and pause the video and wait for the rest of these resources to come online, and I'll be right back. All right, welcome back. Here we go. Let's go ahead and take a look, and there it is. Everything seems to have worked successfully. Now, the CloudFront distribution took 2.5 almost minutes to deploy. Last time I timed it, it was about 3 minutes. This was a little bit shorter, but it really depends on how busy CloudFront is. But after that, everything got created successfully. So notice what it did was it created these resources. And now if I go into my S3, what I should find is a bucket with all the static content in there. Excuse me. Let's find the S3 bucket. Let's call it code is life, and there it is. That's the dev one, and there is my static content, right? And now let's go take a look at the CloudFront distribution. Go ahead, there's the CloudFront distribution, and I should be seeing, yep, there's the CloudFront distribution, the alternate domain name, the fact that it's enabled, everything is there. And if we want, we can take a look at the tags, and there it is. There's my environment, and there's my name. This is now a Terraform managed CloudFront distribution. All the steps, the 47 steps or 47-minute long steps that I created the video, by the way, that didn't take 47 minutes. That last time I did this took roughly 4.5 hours in order to do everything. I just edited the video down in the last video. All of that stuff took maybe at most, I'm gonna say 3 minutes, 4 minutes maybe to do. And it did all of that for me automatically. So now what I'm going to do is, using an incognito window, verify for you that everything did get deployed as expected. So let's go to codeislife.de, codeislife.de, and voila, my content is coming up. Let's try hello. It's going to respond. Let's try https://www.codeislife.de. Comes up in the HTTPS case as well. Let's try the naked apex, https codeislife.de. That works as well. That is also being protected. And let's try without HTTPS, just for the sake of completeness. Yep, that's working too. Beautiful. The entire infrastructure that took me 4 hours to create took roughly 4 minutes to create this time. And this time it is also guaranteed to come up the same every single time. That's the power of Terraform. In the previous video, if you remember, I forgot one step. I think I jumbled it up backward and forward. This time it took 4 minutes, and it cannot be wrong. As long as you have troubleshot your code and make sure it works every time, you've gone through that exercise. Now, next time you deploy this as many times as you like, for example, why don't you go ahead and start a website hosting business using S3? This will be lucrative. Every time somebody asks, hey, can you deploy my website? Sure, you have your static content. Here you go. Okay, just go ahead and deploy it, and it will come up in 4 minutes. Charge them a few $100 and send a few my way. There you go. And that, in a nutshell, is how you do that. Now, what I need to do is I need to remove that that zone from my Terraform, because if I run a destroy, because I created this infrastructure, but now I also have to destroy this infrastructure because it's going to, incur costs if I leave it running. But the only thing I don't want to destroy is that Route 53 zone. The reason I don't want to destroy that Route 53 zone is if I go to Route 53, and if I destroy that zone, recreation of that zone and then propagation of those DNS records takes 24 to 48 hours. That's a very long time. I am not in the mood to do that. So in order to make sure that Terraform stops tracking that, I'm going to use what is called a state remove command. And from the state remove, what I'm going to do is I'm going to tell it, hey, I want you to stop tracking this Route 53 domain, which is the codeislife.de hosted zone, from your state. That way, when I run the destroy command, which is actually a destructive command, it will clean the entire resources up. Everything that you created, it will clean it up. I just want to make sure it doesn't destroy that particular hosted zone. I'm going to hit enter. By the way, all these commands I'm going to provide in the description below. Don't worry. And there it is. It removed successfully removed from one resource. And now, when I run this Terraform destroy command, this particular hosted zone will no longer be destroyed. So let's go ahead and destroy these resources now that we have brought them all up. Time to have some fun and destroy it. I feel so evil. Apply, and instead of apply, the command that we're going to run is destroy. Not destroy, destroy. Terraform destroy var-file dev.tfvars. This dev.tfvars is obviously where the values of those environment variables are contained. Let's go ahead and hit enter. It will again run a Terraform plan, and it will tell you in an output what it's going to destroy. And let's let it run for a second, and let's see what it tells me it's going to destroy. It knows that it created all this stuff. It's making calls to the AWS backend and letting it know, hey, I need to, oh, yes, there you go. The plan succeeded. If you hit type yes now, I'm going to destroy these 24 resources. Are you sure you want to do that? I'm going to say yes. And what it will do is it will clean up everything for me. Whether it's the buckets, objects, the CloudFront distribution, the IAM resources, it will destroy it for me. I don't need to take care of the cleanup on aisle 1. Have you gone through a demo or a class or something in the past, and then you forgot to clean something up, and you got a bunch of bills in the AWS environment in the following month? Well, you don't have to worry about that anymore. Terraform will make sure everything gets destroyed. In this case, the only exception being the hosted zone. Okay, so let's go ahead and let this Terraform destroy command run. And we can conclude. Actually, you know what? That is it for today. I'm just going to go ahead and hit pause for a second on the video recording and let the destroy run. And you will see, I'll come back when the destroy succeeds. All right, there you go. The destruction is complete. Very destructive. I feel like doing my evil laughter. 24 resources have been destroyed. And if I want, I can create or destroy this as many times as I like to by running those commands. There you have it today. That is it for today. Thank you very much for joining me. Until next time, I will see you later. Go ahead, feel free to comment on the video below if you have any questions. And I would appreciate it if you could share the content and subscribe to the channel. Thank you.